Right, new microphone. Let's see how this goes. So while we're waiting still for some welding to be done, got to get on with some electrical jobs. This particular video we're going to have a look at the design and the build of the battery pack which lives in the guts of the cargo bay. So we'll zoom in a little bit. We can see a little bit of context. This is the bus overall. We're going to be working in the very back of it, underneath everything, just by here. This is where the two battery packs are stored, and all of the rest of the electrical systems here as well. The pack itself looks a little bit like this. It's basically aluminium extrusion with a load of 3D printed bits, and the batteries just slot into that and are all kept together with the terminals. There's a little bit of compression in there just to keep everything together, but nothing crazy. So we'll be printing these brackets and braces for the top of the battery pack, which are going to hold things like the BMS for this one. BMS screws up into the bottom of these brackets, and then those go on top of the battery pack. So I'm going to use some T-nuts to screw those down with. This is the isolator and the fuse block, and the braces just again keep it sturdy, stop it from going anywhere. They clip onto the top of the bolts. And then it all fits together like this. Obviously there's a lot of terminal covers to print as well. All of the designs for this are on the Printables website, which I'll link to in the description. There's also this 350 amp Anderson connector bracket, which just again stops everything from rolling around on top of the battery pack and gives you something, permanent to mount everything with, and then in that way the whole pack can be removed after it's been disconnected. So yeah, we'll print those out and get to fitting it. Update this pack. So obviously start with isolating it by turning that off and unplugging it. Now that battery pack's completely away from everything else. I'll disconnect the BMS, because the first job we'll have to do is to replace these copper terminals on the BMS with some new ones which will be shaped to fit directly onto the negative battery terminal. So after taking it apart, this has already been modified once, but the idea being that we'll just use an angle grinder to cut up some sections of this flat bar, which is just earthing strap, common stuff. With those two sections I'm cutting off, we'll sand it down the edges, tin them, and then solder them back in place here, and then just form them up so that they actually fit on top of the battery as well. There's a lot of heat that has to go into this because the copper obviously dissipates it very quickly. You'll need to probably double line it like I'm doing here, just to get enough heat in to get that solder flowing and get everything molten enough to remove it easy enough and add the new ones. That was hot. They should fit together something like that. Once they've been tinned now. Again, 2 irons, half the job. Even then it takes a jump cut.
I was wondering how you talk to these guys. I was reading in real time when you're talking to somebody. You're not.
And then the same to get it on the board. Obviously this is sped up an awful lot compared to the amount of time it actually took, but they were nice solid connections by the end of it, and then with 2 holes drilled through those bus bars, this all then just fits perfectly on top first take. Of course not, it took a few times to get that right. And then with some T-nuts into the aluminium extrusion, it's screwed to the top of the battery pack, and then that's going nowhere now. It's a nice sturdy connection to everything.
Go have a baby at 30 and come back to her career.
And then so now it's just a case of getting the Anderson connector bolted into the bracket that's printed for it. A couple of long bolts, washers, nothing crazy.
No, I was.
And then again, just with some T-nuts that can be attached to the frame of the battery.
It's so heartbreaking as a new parent.
Now building this, it's just a matter of adding this battery isolator onto a small copper bus bar, which then has some bolts threaded through to it, allowing you to attach the fuse. So I'll just tighten that one onto that one. And then a bolt through there, and then the 3D bracket, or 3D printed bracket for it, has just got some holes to take those bolts in. Tightened all down, and then we can fit the fuse. A little bit of bolt and some ugga-dugga to make sure it doesn't go anywhere. And then we can fit it back to the battery. Connect the terminal up there. And then we balance the battery pack precariously towards us so that we can fit the Anderson connector bracket into the T-slot nuts in the aluminium extrusion. That gives us a nice sturdy point for the main connector for the battery. Add the main positive to the fuse now and just give it another little bit of ugga-dugga, make sure that doesn't go anywhere, and tighten down the braces to the top of the battery. So with the second one on, that's looking pretty sturdy and just like the one behind it. So now we'll just connect the main negative up to the BMS now. Start it by hand and finish it with the ugga-dugga. Finally get the BMS sleeves attached. These also need a bit of a tidy up, but we can do that again. And then the Anderson connector can just... All that's left now is one last check. Make sure everything is connected solidly. That main positive lead needs to be trimmed down a little bit. Once I'll get some new crimp terminals, I'll trim that down. But everything looks solid. We do have some solar today. Not a lot, only a couple of amps, but should be enough to activate the BMS. So in theory, turning on the isolator now should activate it, but it didn't. So to force it, turn off the other battery, hoping that it would push all of the charge into the new battery, which just resulted in all of the power being lost. Not great. Then turning it back on resulted in battery number 2 saying that it had a short circuit, which it definitely doesn't, otherwise there would have been a lot more of a bang. But after that, it seemed that the battery number 2 BMS is activated and it's on. And then once this timeout expired for the short circuit warning, battery number 1 also turned on. Not quite sure what happened there, but because there was no loud explosions or bangs and I was still alive at this point, I didn't think that there was anything too wrong. I can only think that it was something to do with the inverter that was probably just making it appear that there was a short circuit with the large inductive load that was being added. But there, sure enough, once the timeout for that short circuit expired, it seemed to reconnect and was sharing some current into the battery number 1 that had just been re-added, and there we can see discharging at 5 amps into battery number 1. So that in total is getting about 8 amps in combination with the solar. Over time they'll eventually balance out, but there we go, another jobbed. Next time you see this, we'll be ripping it all out and replacing it all properly. Catch you soon.